Hello, everybody. My name is Enrique, and welcome to this quick training session on network traffic analysis using a critical tool known as Wireshark. For any aspiring IT or cybersecurity analyst, understanding what's moving across your network is essential. Over the next few minutes, I will cover what Wireshark is, what a packet capture file contains, and lastly, I'll be using the 7-layer OSI model to better understand and analyze frames within our packet capture file. Okay, so first, Wireshark. Wireshark is a network protocol analyzer. It allows cybersecurity professionals to capture and examine data packets flowing across a network. Some great uses for this tool is that it can identify malicious activity, troubleshoot network issues, verify encryption is working correctly, and also perform incident responses and forensics. We go on to our actual packet capture file. So we identify that with our .pcap as up top as I'm pointing up. So this file is an output of capture session. It's raw data we analyze. It contains information for layers 2 through 7 of the OSI model, including the payload data and actual timestamps. To get a better understanding of what we'll be analyzing, I'll give a quick rundown of what the 7-layer OSI model is and its relevance to Wireshark and cybersecurity. So we'll start off with layer 2, which is a data link layer. It's the layer that helps identify the physical address of devices. Its relevance is that it can be used to identify MAC spoofing, which is when someone changes their MAC address to impersonate another device. Next, layer 3, the network layer. This layer is responsible for routing traffic between different networks. Here, we can detect unauthorized network access and even any routing issues. Layer 4, the transport layer, monitors what services or applications are being used. Uh, Next, layer 7, the application layer, shows the human readable contents. So here is where we will usually find any web-based attacks or phishing attacks. Okay, we'll get into our actual file here. Here we will be analyzing two frames, frame 8, the unencrypted frame, and then frame 136, the actual encrypted frame. And as you can see, I clicked on frame 8. We'll go under layer 2 first. And here we go under 108.02.11, which is the Wi-Fi standard. And we click the drop down and we see we have our source and destination address. These addresses are MAC addresses, which, as stated above, belong to a physical device that help identify it on a network. And it also helps devices within that network to communicate. So we're done with that. Layer 3 can be found under the Internet Protocol version 4 dropdown. Here we have our source address and destination address. These addresses are identified through their IPv4 structure. These IP addresses are used to route traffic of local devices between different networks. Click that. Our layer 4 can be found under the transmission control protocol dropdown. Here we identify the source port and destination port. This layer is important as it allows applications on different devices to communicate, allowing for reliable exchange or delivery of data between those applications. Examples of applications can be web browsing, email clients, and even streaming services. Next and lastly, we have our layer 7, which is our line-based text data. And we click on it here, we click this guy. Here And this layer, the human readable part of communication, is only viewable if traffic is unencrypted. And here to the left, you can see the data bytes. Can't really make anything out of it. And to the right, we see the human readable part, which is given to us in the message. These are the times that try men's souls, is what it's trying to tell us. All right, so we're finished with those. We've identified all layers here, so we can move on to our encrypted frame, which is 136. And that is this guy. Here, only layer 2 is visible. And as we can see, we have our source address and destination address as MAC addresses. Layer 2 is only visible because network devices need that data within the layer to physically forward data from one to another. And as we can see, layers 3 through 4 are not in view, but we can kind of better understand how this message or this frame is encrypted, and we find that information here through the WEP parameter, which stands for Wired Equivalent Privacy. And the WEP generates a key stream that hides IP, TCP, and application data, those layers 3 through 7, as we went through with frame 8. All right. To conclude, we went over the importance of Wireshark and its relevance in IT and cybersecurity profession. It's an essential tool, a critical tool, one that should be used by all professionals. We dove into the frames and got a better understanding of what we were looking at, comparing data and understanding its role in each layer of the OSI model. And yep, that concludes my training session. Hope you enjoyed.